So let's start discuss topic for today. We'll talk about the main packages in Golang. It's IO, OS, and context. This is our agenda from today. Apart from these packages that I mentioned, we as well will learn a bit of concurrency, just brief overview, because it will be required for understanding of context. Let's make a start from IO package. So basically what IO means, it means input and output. So each program has input, some processing, can perform some processing, and has output. For this, in Golang, we have IO package and has several structures that you already seen, such interfaces like reader and writer. We discussed them on lecture regarding interfaces and OOP. Yeah, let's move on. Where is IO package used in standard library? It's used in compression algorithms like Gzip, for instance. It's used in archives like zip and so on. In cryptography package, in buffers, byte slices, and strings. So there is most popular types and methods that we have in IO package. You can find all of them by the following link. And these functions and types we'll consider on the current lecture. Yeah. Let's guess for a couple of seconds and think what is the most popular interface in Go. The second popular interface in Go is a reader, the third is a writer, and the first one I can give you a couple of seconds for think, and you can send it in the chat, for instance. Right, ready, steady, go. And the most popular interface in Golang is error. You will use it on daily basis. So when you create any error, use this interface. And even reader and writer interface has this error type, returns this error type. You already know about this interface from lecture about errors. So yeah, we already captured those interfaces. Basically, those interfaces shows us nice interface segregation principle from the solid, which means that better to have one small interface instead of one big, and we can combine them via composition in Golang. Yeah, you will see this a bit later. All right, let's check like how to use the reader, for instance. As I mentioned, strings package use reader interface. Via this method, we can create some reader, put there some string, and we will able to read it. So we as well created some slice of bytes. Here we have only 4 bytes, and we starting the loop. In this line, we basically read everything, and we read everything that we're able to read. So not more than 4 bytes. So basically, it will be those letters except E on the first iteration, and we will just print them into output. Then we'll make one more iteration, and we will print E later. So output will look as follows, and read as well can return end of file. So it's not an error, and you have to handle it properly, like I made it here. For instance, in case this error, we have to double check that it's not an end of file. In case it's end of file, we have to break. In case it's really error, then we finish our program. Yeah, and in the end, we just print our output here. So yeah, how it works and looks like. And let's once again consider what actually means this read signature, what we have in the parameters and what it returns. So as you can see here, we move some slice of bytes as a parameter to which we want to read, and it returns number of bytes that we read and an error. Same in writer. Why it's implemented by the following way in the reader to prevent memory leaks. Golang developers move this part to us, and be able to control the number of bytes that we want to read, basically as here. We allocated our memory once for 4 bits, and then we reuse it across the whole application. If you want to read as much bytes as possible, we have read all function in the IO package, which we'll consider a bit later. Yeah, this was a first example. The next one, it is well with the read operation, but a bit more complex. What we do here actually, this function will count letter for us. For instance, we accept some reader as a parameter and return the map, which will return the letter and number of counts of this letter. Let's make a buffer, allocate memory once for 2084 bytes, create structure for our output and start the loop. We read from the buffer, check the range. Is it from A to Z or from A to small z? And in case it in this range of the letters, then we move this letter to our map and increment count once. When we reached the end of file, we return the output. When we reach the error, in case something went wrong, for instance, we return actually an error. Yeah, so you have to consider the error end of file not like an error. You have to handle it properly, and apart from that, you can get actually real error that we'll call like error unexpanded end of file. So which means you have to handle this one as an error. Yeah, and yeah, this format can be a bit tricky, but it means that we want to read only bytes that we read from the this function, not all of this one. Cool. Yeah, let's test this function. What we can do, we can create a reader, we can add Golang United here and count letters, and the output will be as follows. As you can see, I letter we've seen twice, and letter we've seen twice as well. So yeah, you can check this example by the following link if you want. The next one is example with a writer. So what we do here, we create a buffer, and we're able to actually write to this buffer via fprint function, which implements writer under the hood. So here we use buffer, but it can be the file or somewhere else. Yeah, then we just want to get the string from the buffer and print it. So output will be as follows. The next one is a seeker. It can be a big tricky one. Interface. So basically, when it's used, when you want to move your position in the text, for instance, in some file, in some structure which you read, to some number of symbols. So offset means the number of symbols to which you want to move. Whence means their type of when, so it can be when start, when end, or when current. It means position. From the beginning of the file, for instance, you want to move to some number of characters, or from the end of file you want to move to some number of characters, or from current position. So it depends. And for this we have whence. This first return value means the offset that we entered. I don't know why it's implemented here, but I think it just in order to double check that we read it properly and move to proper number of positions here. And error means that in case something went wrong, for instance, we achieved the end of file and we went out from boundaries of the file and something like this. Let's check some of the examples. For instance, here, the quick brown fox jump over the lazy dog, created the reader, created the seeker. What we do here, we start from the 16 position. So basically, it's from it's located here. Here are the 16 symbols. We print. We check that everything is okay. We not went out of the boundaries. Yeah, we can see that our string is longer. Everything is okay. So what we do next, we just print this current location, create a buffer, and start to read as we want. So we allocated only 3 bytes. Check that we didn't reach the end of file. And yeah, basically that's it. As far as we didn't reach the end of the file, we read into the buffer only 3 symbols, which is F, O, and X. And yeah, printed into the standard output. Cool. The next one is a closer. Closer is as well quite popular interface, used almost everywhere, where we need to close some memory to avoid memory leaks. For instance, when we work with files, with buffers, and so on. For instance, here we used a logger, and in case something went wrong, we want to return an error, be trying to close this logger to save our memory and just to stop use it. And in case we got error while closing, we return an error. In case everything is okay, we just return the nil. It as well can be used when you connect to the database. So when you connect it to MongoDB, for instance, you as well want to close your connection when you stop working with Mongo, or when you connected to some message broker like Kafka or Nuts or whatever. Yeah, so a lot of structures use close. And anyway, in case you want to implement something that's related to input, output, take a look into IO library, and it's can be possible that you have to implement some interface first instead of creating your own one. Well, let's move on to the interesting thing, and which shows how nicely implemented interface segregation principle in the Golang. So as you can see here, we have combinations of our interfaces, which we already captured, like reader and writer can be reader writer. And as you can notice, each interface has ER in the end. It's a common suffix in Go. So when you create interfaces, you should follow a standard, which means that ending ER like used for interfaces. Cool. Yeah, so we have read writer, we have write closer, and write seeker. Read writer used when you want to implement something that read from somewhere, write to somewhere. Write closer, for instance, I think when in OS file we implement this write closer as well, and write seeker when you want to change the position and write something inside of the file. As well, we have read-write closers, which we'll consider on the examples a bit later, and read-write seekers. So it's great when we want to create some structure that will read something from file, write to some file, and be able to close connection to prevent memory leaks. All right, this is an example of combining reader, writer, seeker, close interfaces. What we can see here, we create a structure for buffer. Buffer implements close method, able to reset it. And we have read-write closer variable, which is buffer. We can write something inside of this buffer, then allocate some bytes memory, start for loop, and start goes through this. So basically, we read from the buffer and print the data which we read, and close our read-write closer. So yeah, we used full functional of read-write closer. We write something, we read something from the buffer, and finally we close our channel. We finished with our work. So the result as follows. And as you can see on the first iteration, we read just 5 bytes from below, and we reached the end of the file on the next iteration. So the total buffer looks as follows. Right, and the next one is the example with usage of Gzip reader and how nicely, and it as well shows how nicely interfaces are implemented in Golang with implicit deck typing. So what we do here, as you can notice, it has closure as well here. So we return the function, and we have function that means build Gzip reader. So it's focused on the Gzip archives. We read from the file. In case something went wrong, we return the error. In case everything is okay, we create from library Gzip new reader. And if something went wrong, we again return the error. And then if we read everything correctly, we want to close our Gzip reader and our OS open as well, and return the nil instead of error as far as everything is okay. How it will look like in the main function will look like follows. We have some file, as you see on this example we already read, and so on. And when we read information from the file, we can count our letters using the same function and just put inside our reader. So, and in the result, we'll see the count of letters inside of this file, which is good. The next, other interfaces in IO package that quite not so popular, but they exist. So multi-reader allows us to read from multiple readers. Multi-writer do the same, but writing. And we can, with limit reader, we can set some specific number of bytes that we allow to read and not more than 10. All right. And it looks as follows. We created few readers. We created strings, like first reader, second, third, and we executed our function multi-reader. And we can read one by one from all of these readers. basically, yeah. And then we have IO copy, which quite interesting function as well from the package IO, which allows us to print from the reader to standard output directly. So in the standard output, you will see the following result. Yeah. All right, we finished with IO package. I think it has several of interesting functions, and you will use it in your home task, which I'll briefly explain in the end of the lecture. Cool. The next is OS package, and yeah, I printed here this image, which show that OS package able to use any operation system. So it's independent from the operation system. It supports Windows, Linux, and Mac OS. So all the functions that OS package has will function properly on both of the systems, and not without depending on the file system of this operation systems. Like, yeah. And let's consider what we'll learn from OS package today. OS package has several interesting functions. I printed here only the most interesting ones. You can see again all of them by the link that I paste here. Anyway, the first function allows us to create a directory, not depending on the system. So on Mac OS, Linux, or Windows. And in case something went wrong, we return the error, and per means permissions in the file mode. We can create several directories. We can create temporary directory. We can create some syscall error, create pipe. We can read it from the file. We can set environment variable and use it in our application, or it should has as well get environment variable, which allows us to get some environment variable from value from environment variable from our operation system. Again, temp directory. Yeah. Quite popular type as well as a signal. So signal allows us to finish our application gracefully. So it listens into the events that happens with our operation system, and in case something went wrong and we want to terminate our application, first of all, we can listen this event that our application going to be terminated, finalize all the work in our program, and then finish it gracefully. It has as well file, which allows us to do CRUD operation with a file, create new files, create temporary files, use different modes. It's like permissions for the files, which we'll consider a bit in our lessons as well. So yeah, let's consider some of them and check on the examples. Cool. The first is open file. What we do here, we have some file with nodes, and we want to open this file or create new one. And we mentioned it here. So OS O, RD, and WR means that we want to read from this file or write to this file. And here we said like, in case we're not able to read or write to this file, it doesn't exist. We want to create new one. And here the permissions that we set. So basically, it's from Unix operation system like Linux, and you're able to set the permissions in bytes. So for instance, 755 allows to everyone to read and execute the file. In case something went wrong, we return the error. In case we want to finalize our work, then we close the file and finish with it. All right, let's move on. The next is makedir, which allows us to create a directory, as I mentioned. So, for instance, we want to create this directory, and we set the following permissions. As you can see, they look a bit differently because it means that allow to user or some group of users execute the file. But 0755 means that anyone able to read, write, or execute the file. So this permission is a bit lower. And we check in case this directory already exists, or we got some of the error, then we can create, can log as fatal and finish our program. Anyway, if we created the directory, we're able to write into the file, for instance, the following text. So we have to put inside for OS write the slice of bytes and set permissions that we use. For instance, as you can see here, 0660 means that user or group of users able to read, write, but not execute. So in case it would be some binary file, we will not able to execute it, only to read from the binary file or to write. Nice. The next one, it's a setting of environment variable, which is quite useful. So basically, each program, each application, each service that you implement will have probably environment variables. You will have deployment configs, which you have to manage as well. And in environment variables, we can set, for instance, URL by which our application will work, some URL to database, URL to the next service that we're going to use, some type in which we run our application. So it can be debug mode or production and so on. We can use as well for implementation of feature flags. For instance, in some of the, you can set environment variables with the name of the feature, like feature and the name, enable, and you can send in the value disable, like true or false, and by this way your application will behave a bit differently. What else for set environment variables we can use as well? I guess is most of the examples. Yes, so in services, basically you will use some meta information for your application to make it not independable and more flexible. So you can change some database name to, I don't know, not to your dev environment, to your staging environment, and so on. So in this particular example, what we do, we set environment variable by ourselves. And the key here is a name, its value is Gopher, and here the key is borrow, which means like home where Gophers are living, and we entered path here, so user Gopher, and printed the following string into the output. So we've checked first of all the name, Gopher lives in, and borrow, which is true. You can play with it by yourself by the following link. Cool. The next one is how we can create temporary directories. we make temporary make dir temp. What we do here, we create a temporary directory with name example. We check that everything is okay. And when we finished with our work, we want to remove everything like inside of this directory and including this directory. So we're cleaning up. The next line here means that we want to join the file path to this directory with some temporary file, and we want to read some content inside of this file, and we use the following permissions: 666, not the best like number, but what it means that all users can read and write but cannot execute the file or folder. So yeah, so they will have access to temp file, but it's not executable in case it's a binary file, for instance. Yeah, and we log in case something went wrong. Cool. All right. And the last but not least, regarding OS package, is I wanted to show how we can gracefully shut down our application. So in case, let's assume that something went wrong and we've got interrupt signal, we want to handle it gracefully and close all of the connections right inside of the database. For instance, our service interrupted and change something inside of the database because of it, and etc. So we want to gracefully finish our application. Because of that, we have OS signal and OS interrupt, and we can listen the notifications. We basically what we do here, we'll discuss it in a sec. What that is following signature means. Basically, here we're creating a channel with type OS signal. Yeah, and send some of the value. Yeah, and here, when we getting this notification, actually with interrupt signal, what we do, we create the context, which we'll as well consider, and yeah, close out the operation gracefully. So yeah, just here I've seen that used a couple of things from OS package, which is nice and quite popular. So basically you will see the following code almost in each service that you're writing on a Golang. It can be written on any protocol as well. So in HTTP or gRPC, it doesn't matter. So it's quite often that we will use a structure. All right, and let's make some brief introduction to concurrency in Golang, because it's mandatory to have for understanding of context in Golang. Yeah, but details, and you will a bit dig deeper inside of the concurrency on another lecture that will be basically fully for concurrency. Here we just make short introduction to understand what does context mean. First things first, what means coroutine? Coroutine is a lightweight thread managed by Go runtime. But yeah, and this image injects like that. Basically, it allows us to run our functions asynchronously. This can be as a main thread and or main function, and this is a workers, some of the functions that run asynchronously. So basically, for running any function asynchronously in Golang, you just need to add Go keyword in the beginning. Yeah, so for now, you will learn details on another lecture, but for now, you just need to understand that Goroutine is a function that runs asynchronously. So we can, in parallel, run several functions, make latency of our application lower and throughput better. For instance, here is a simple example how it will work. So we have two functions. The first one, numbers, execute numbers from the 1 to 5 in the loop. And we have package time here as well, which do sleep for 250 milliseconds. And then just print the digit. And same with alphabet. Well, we're running these functions parallelly, so you will see in the output, like, first of all, we print the ones, and we print an A, and so on. So they work in the parallel. We will not see something like from 1 to 5, then from A to E. Like, we will see the mix of output of these functions. And because not to terminate our program, we added sleep here, which is anti-pattern, better to use wait groups, which we will learn as well in the next lecture. Here is just a brief overview, which allows us to not finish our application for 3 seconds and finally wait for the ending, and then only to terminate it. Channels. Channels is as well quite useful thing which you will constantly use. Basically, channels allows us to send data between our coroutines from one coroutine to another. And you can interrupt coroutine either by the channels, because you can send some value that this one coroutine finished to work and another please stop work as well. Yeah, and so on. Let's take a look into the example. For instance, here, it's a basic example of pattern producer and consumer. What we can see here, we ran producer, which asynchronously send the values inside of the to the channel. So here is the definition of the channel. We used buffer channel with type integer and keyword make, and we said that we can allocate here 3 elements. So in case we want to add one more element, we have to wait until it will not become empty again. And we add some value inside of the channel, for instance 0. What we do here, we start by this line, we start our Fibonacci function, which is getting as a consumer result inputs to as a parameter inside of this channel. We got notification, right? Doesn't matter. So it's getting some parameters and just provide for us Fibonacci result. And when we got Fibonacci result for all our inputs from 0 to 10, we can quit our program and send 0. Just any number can be actually here for quitting. And here we use as well select statement, which works as a switch case, which you already know. It allows us to manage our channels. So in case we receive the value from this channel, as we send here, then we do calculation Fibonacci. In case we've got quit channel with any value, for instance 0, as we can see here, we're just quitting our program and print this message, and execute return function, and our main function is interrupted. All right. Select statement, yeah, which we already captured, allows us to wait on multiple channel operation, combining coroutine and channel with select as a powerful feature of Go, yeah, which is true. So yeah, and basically this picture illustrates how coroutines communicate between each other via channels. So basically, one coroutine able to send something to another by the following where, yeah, via channels. Select statement, one more example. What we do here, we created two channels. Again, in one channel, we send 1, the second 2, and we iterate twice. In case we received 1, we print that we received 1. In case we received 2, we print that we received 2. Looks straightforward, isn't it? All right, and finally, we went to the final topic of today's lecture, which is context. Context is right. Yeah, context is a quite popular one in the Golang. So it allows us to cancel all our Go routines at once. So basically, we can create several Go routines to which send the context. And in case something went wrong, or we want to interrupt all of these Go routines at once, we use context and execute cancel, deadline, timeout, and etc., which we'll consider. Yeah. So basically, context carries of deadlines, cancellations, and request scope values across your API boundaries. The interface itself looks as follows. We have done channel, which returns empty struct to save the memory, because int will cost you 8 bytes, but struct loads nothing. Error, in case something went wrong. Deadline, so it accepts time as a parameter, and in case, and we can check actually do we have a deadline or not by OK statement, and the value. So we can send via context some metadata between the channels or between services. Either in case you use gRPC, it allows to send context via metadata. Yeah. Let's move into examples. And here we can see high-level view of the context. So it has background, value, and cancel. It has 3 data structure. So any value context must have background, but I think it's a bit wrong. Any cancel context must have background as well, but not mandatory to have a value. And it can be used anywhere for HTTP requests, for instance, in database queries and RPC calls, and etc. So, and actually, except of this background that you can see here, we have as well to do. And let's understand what is the difference between them. Background and to do both send value nil all the time. It can receive any value. It doesn't have a deadline. It doesn't have any errors, and it can't send any done. So basically, usually background requires for creation of any of these context, and to do used when you don't know which context you're going to use in your application, and you shouldn't use it in production for sure. Yeah, so as you can see here, this statement from the documentation. you use to do when it's unclear which context to use or it's not available. With cancel. So context with cancel allows us to close some job with all of the examples as we've seen with closer interface in IO package, same almost here. So in case you want to finish work of several of Go routines by the same way, but by for some reason you can use this function is with cancel. So what it does, it receives the parent. So as I mentioned, it must have at least one context inside, so it can be background or to do if you don't know what context you're going to use. It returns context and cancel. So this is example of context with cancel. What we do here, we have some gen function. What it does for us, it generate numbers and send them inside of the destination, I think. All right, and here we accept all of the numbers that we send. For instance, first one will be 1, the second 2, and etc. We'll print all of them. And as far as we have defer with cancel, once our application is finished, we make break. So we printed all of the numbers from 1 to 5. We make a break. Defer executes in the end of our program. And here, this Go routine receive channel done, which means that our application is finished, and we execute return to prevent memory leaks from Go routines. So always try to go out from your Go routine when you finish some work. So basically that's it. It's simple as is. With deadline. With deadline, so basically it works quite same as with cancel, but we can cancel by ourselves. But apart from that, we're able to add here some time to which we want to finish our application. For instance, I want to finish today at, I don't know, 5 p.m., right? And I set this time there, and my function will stop work on this period of time. So I will get this done channel in this particular time. Okay. And this is example how it works. So we added some constant, that means a short duration, and we added just 1 millisecond. We added here as well to make it with another type. We made it with time now, so current time, and added just 1 millisecond. Executed with deadline, put a context background, as I mentioned, and then duration when we want to finish. Executed defer with cancel, so which means that when we will meet the deadline, we'll finish the function. And yeah, first of all, we went to this case. So in case we overslept, and in case something went wrong, where our deadline is achieved, we received done channel and finished our work here. And as well, we're able to print the error, and error will be something like we achieved the deadline. Same timeout looks quite same as a deadline, but we put inside of the parameter not time but duration. But basically, what we made here, under the hood, it works by the following way. It just add time now and add some duration that we send to the parameter here. So basically we can specify, for instance, 5 seconds, and then our Go routine will work no more than 5 seconds, and then we'll get context done and finish his work. All right. And yeah, quite same example, but as you can see here, I don't need to create this duration variable. I'm just directly add short duration constant inside of the function, do some work, and yeah, finish it. Context with value. It's a useful thing when you need to send some metadata between of the Go routines on between applications, either in case you use gRPC. For instance, you can put inside some correlation ID. It's useful when you have several services and you want to see ID of the transaction which happen on all the services and traces gracefully and improve your observability as well. In case you want to know what kind of user make request to your service, and so on. So first, basically, it's used when you need to send metadata between your Go routines. But you need to be sure that you use the type that you use is comparable, and it shouldn't be built-in type from Go, like string, integer, float, and so on, because you will face these collisions. To avoid it, you need to create your own type. You will see the example in a second. For instance, as I implemented here, this example, we created type context key, this type string, but it's our own type. In that case, we will not reach collisions. We created some function which receive the context and the key check in case we able to get the value for this key or not. In case value is not found, we return the following output. In case value has been found, we return message that found value and the value itself. So for instance, we created key language, and we used this value context background, added key with value Go, as far as we use the same key. And yeah, we were able to put this value inside, and we send this context inside of the function, and we check that this actually value is located in the key context and printed it. But in case we want to find something by key color, we will not able to get it because we didn't put any value inside. Cool. Basically, that's it. I open for your questions.